Hi, welcome to Project Geospatial. I'm Adam Simmons, and in this episode, we're going to dive a little bit deeper into the fire data I was explaining about last week. Show a little bit preview of that with I think the Washington Post was showing wildfire maps in California, how the wildfires were growing. But I want to dive a little bit deeper into the data this episode. So for that, first thing I'm going to do is pop up real quick Google Earth, preview what I showed last week. So what this actually is the fires data imported from the National Forest Service. And I'll bring up the website here in a minute too so that everybody can see what's going on. But if I bring up the panel, what I did was load up the KML from the website. And we can see a lot of what's going on here. And let's hold on just a minute while I change a couple things here. So the fire data can be downloaded from multiple different ways. KML is one of the easiest places to visualize the data very, very quickly, but it's not a great way to manipulate the data after the fact. So I'll show you where to get the source data here in a second. Sorry, a couple logistics I forgot to figure out before I activated this the show here. And I will, let's see. All right, let's switch back to Google Earth. And then I'll open up the MODIS fire detections here. So MODIS is one of the satellites that NASA and NOAA managed to detect wildfires. It works parallel with the VIIRS sensor, and forgive me, I don't know all the logistics and different the scientific missions that these things are tasked to work with. But one of them is primarily looking for wildfires. They have a IR and near IR sensors on board, and it allows it to detect wildfires around. Primarily the United States. But you'll see when you go into the VIIRS sensor that it does detect global uh, global global data. So with the wildfire data here, we can see this is actually recent. The KML is updated. Let's see if we can dive into the KML data a little bit more. It is updated on a refresh rate of every 15 minutes. Typically, the data doesn't come in that often. I want to say the data comes in. I don't think it's near real time from MODIS though. Might be hourly. This is right here, updated 9:15. So was it Central Time or Mountain Time? This looks like Mountain Time. But you can dive in. You can see here that I can show 1 kilometer fire detection, centroid footprints, area of interest, boundaries, etc. If I and this is the massive car fire going on up near Reading I was going over last week. So this is the time series that's going on. And here's the fire data web services they're offering as well. So they have a WMS service and a WFS service that you can use. So you can see MODIS, different bands of VIIRS, and you can also look at it from the perspective of Landsat. The other thing you can do is go straight to the source. NASA and this is coming out of NASA, but NASA and NOAA Visible Infrared Imaging Radiometer Suite, or VIIRS. So you do have to sign up to a register before you can download some of this data. And the raw data is not as easily interpretable as you would like to think. There's a there's a lot to it. It can be a little bit overcomplicated, and I would encourage you to kind of read up on it before just messing around with it. So here's links to the actual sensor itself. You can see it's the full the information on the satellite, what it's actually designed to do, what different missions it runs. Studying different blooms over Alaska, algae blooms for ocean science, land science here, looking at daytime, nighttime lights over the U.S. If you're wondering where that nighttime lights comes from, that data set, this is where it comes from. Various other things. So this is actually a really good overview of what the sensor capabilities can really do. Changing air quality, to just monitoring even hurricanes over the area. And actually, I'm really surprised. I didn't see. Thermal satellite imagery shows variations in northeast U.S. So actually, I'm trying to look around here, and none of these examples actually highlight the wildfires, at least in the visual examples here, which is kind of crazy. Anyway, NASA also has a window where you can look at the data day by day. So if you didn't really feel like downloading it right away, but you want to look at it through a web-based viewer, you can kind of see it changing. So let's go up to August 10th real quick. So this is the perspective of August 10th, 9th, 8th. So we can keep on going backwards here. And where this is, so let's kind of zoom into the fires here. You can see this is the car fire that went on. Let's go back in time quite a bit. You can see it's shrinking smaller and smaller back to the source point. Very cool. So it doesn't look to be, oh, that could have been the start of it, not sure. So here we go. We're going to start here on July 20th. There's nothing going on. Starts to explode in July 23rd, 24th, 25th. And look at that. Look at that fire growing. You can see it's kind of going outward between north and south here. And it's more kind of going northwest and southwest. You can see it ever expanding. And a lot of this too is as the firefighters are gaining more control over it, or it's running its course. And here we go. You can see, like I said, now it's more isolated into separate sections. It's not as widespread as before, but it is starting to come down a bit too. Same with some of these other ones. So you can it's interesting to mix this data with terrain data, a map of where all the trees are, the vegetation, and you can start to learn the behavior of how these fires even burn. Mix that with weather conditions like winds, or where the prevailing winds are going and how that influences the fire. It all is data that you can use to predict and analyze wildfires, but also kind of understand where this stuff might happen in the future too, based off this current behavior. But this is a daytime, nighttime feed, I believe. No, this is just looking at the nighttime. There's a daytime thermal anomalies section here as well. Yeah, daytime, nighttime. So you can use this daily to monitor if major events are going on. you might be asking, are all these fires? They are not all fires. These are detecting all kinds of different activity between. So once again, I'm not sure what the threshold they're set this to. Um, uh, the sensor actually detects quite a bit, but to detect things like wildfires, they cut out everything below a certain uh, temperature or energy threshold. Like I said, I'm not entirely sure what what the cutoff is, but this could be everything from illegal oil burning, refineries, power plants, all kinds of different things that could be man-made that are emitting very high levels of thermal radiation that the sensor is detecting. And in another episode, maybe I'll dive into some of those examples of what you might see with a sensor like this, other than wildfires. That may be kind of interesting, especially analyzing this section down here. I'm not going to even speculate at the top of my head what all of this could be. I'm sure this is many different types of activities down here. So, uh, once again, you can go to, let's see, worldview.earthdata.nasa.gov if you want to look at the actual browser-based data. You can always go to jointmission.gsfc.nasa.gov for information on some of the sensor types. Here we go, earthdata.nasa.gov, Earth observation data. And this goes even further for near real time. You can kind of dive into some of the Earth observation options here and get more information on the data itself. Or if you're more specifically interested in the wildfire data, once again, fsapps.nwcg.gov. I actually just, maybe a little bit more accurate to me, but I just usually just type in USFS fire map, and it's the first one on the list for active fire mapping program. I didn't dive too deep into some of the other possibilities and how to break down the data, use the data. I leave that to a future episode or comments. I'm really curious on different ways to how people visualize this stuff. I have my ways. I'll typically bring in a data set like shapefiles or CSVs or KMLs into Fusion tables, do some analysis with that, aggregation of data, isolate certain activity. But overall, there's a lot of different ways to look at this stuff depending on what you're trying to do. So once again, I promised last week we were looking into fire data, and what we're going to do, instead of just you not knowing what I'm going to present every episode, is I'm going to come up with a list of topical items that's going to be talked about in the next couple weeks. And this way you're prepared to know what the next episode is going to be about. And it's not going to just seem like I'm winging it every time. I promise you I'm not. I'm preparing all this stuff ahead of time. It just sometimes it does seem like I'm finagling. Most of the time it's just me trying to figure out this new video software I'm trying to use to broadcast these episodes. So with that said, if you have any stories you like to tell about geospatial visualization, geospatial data, please shoot me a comment, messages to let me know, or corrections on any type of wording. I'm not always the best speaker for these types of things, and I misword things a lot. Feel free to correct me, and I'll bring it up on the next episode. Or if you'd like to join me as a guest speaker sometime, hit me up. I'll see you next Friday at 11 a.m. For the next episode of Project Geospatial. Thanks for watching.